Good morning. This hearing will come to order. I'd like to extend a particular welcome to our witnesses and in particular recognize Congressman Luis Fortuno's presence here with us today. As many of you may recall, today's hearing on near-Earth objects was originally scheduled for October 11th, but we postponed it in the wake of our good friend Rep. Joanne Davis's untimely death. Thus, before we proceed any further, I'd like to express my appreciation to each of the witnesses for your willingness to accommodate that postponement and appear before us today. Your testimony will be invaluable to us as we consider how best to proceed in getting a better understanding of the potential threats of near-Earth objects, NEOs, as well as options for dealing with them. Today's hearing is the latest in a series that stretches back to the early 1990s. We've come a long way since the late George Brown, former chairman of the Science and Technology Committee, led the first efforts to focus congressional attention on the potential threat posed by near-Earth asteroids and comets. It has been a bipartisan effort over the intervening years, and a lot has been accomplished. In that regard, I want in particular to salute the dedication of Mr. Rohrabacher in pushing for continued federal initiatives to detect, track, and catalog NEOs, as well as to examine ways to deflect them if necessary. He has been an effective catalyst for action, and I look forward to continuing to work with him on this issue. As we will hear from our witnesses, much progress has been made in detecting and cataloging the largest NEOs over the last decade. However, as we will also hear, much more remains to be done. In particular, we need to survey potentially hazardous asteroids that are smaller than the ones cataloged to date, but which could do significant damage if they impact or explode above the Earth's surface near populated areas. That's why Congress directed NASA to plan, develop, and implement a NEO survey program for objects as small as 140 meters in size in the NASA Authorization Act of 2005. As a result, I'm disappointed and concerned that NASA's report to Congress failed to provide a recommended option and budget plan for such a survey as directed by the Act. In fact, the report says NASA has no plans to do anything beyond the current Space Guard program at this time. Equally troubling, one of the NASA witnesses will testify that NASA would be pleased to implement a more aggressive NEO program if so directed by the President and Congress, with the implication that Congress has not yet done so. I believe Section 321 of the NASA Authorization Act, which I quoted earlier, is unambiguous. Congress, in fact, has directed NASA to plan, develop, and implement such a program. And we would hope that the President would send over a NASA budget request that reflects that congressional direction. Today, I want to focus on where we go from here. Given the lack of a clear plan in NASA's report to Congress, I hope that our witnesses today will be able to provide some guidance to the committee on the best and most cost-effective path forward for meeting the goal of surveying NEOs down to 140 meters in size. In that regard, there are a number of related questions that need to be addressed. First, I'd like to hear from each of the witnesses about the planetary radar capabilities at Arecibo and Goldstone. How important are they to addressing the NEO task? Second, how can we make the most effective use of capabilities being planned or developed by other federal agencies such as LSST and PanSTARRS, and what role should NASA play in supporting them? NASA's testimony indicates that it has been providing funds to the Air Force's PanSTARRS project so that it will be capable of providing data on NEO detections. That is an interesting development, and it raises the question of whether NASA should also be providing funds to other facilities such as Arecibo and the proposed LSST project, if doing so will materially contribute to meeting the NEO survey objectives in a responsible, cost-effective manner. Third, I'd like to know if there are adjustments to either the timetable or scope of the NEO survey called out in the NASA Authorization Act that would make sense, either by allowing more cost-effective approaches on a slightly longer timetable or by focusing on just potentially hazardous objects rather than on all NEOs. Fourth, surveying NEOs is just part of the task. If we find one that's headed towards Earth, we will need to have good options for deflecting it. What priority should be given to developing deflection technologies versus NEO survey systems in the coming years? And finally, the potential threat posed by near-Earth objects is not isolated to the United States. What contributions are other national and international bodies making to the effort? Should more be done? Well, as you can see, we have a lot to consider today. Fortunately, we have a very distinguished set of witnesses to assist us in our oversight task, and I again want to welcome all of you, and I look forward to your testimony. At this point, the Chair now recognizes my friend, the Ranking Member, Mr. Feeney from Florida, for his opening remarks.
Well, thank you, Mr. Chairman, and I appreciate you calling this morning's hearing, although I did tell you as I greeted you this morning that this is just one more thing for us to worry about that hadn't been on my list until a couple weeks ago when I saw the original notice of hearing. And I want to echo your remarks. We're very grateful to the witnesses because we had to reschedule the hearing on short notice, and we thank you, and we're very appreciative that you're here today so that we can accommodate that emergency change. NASA's Near-Earth Object Program, though very modest in scale compared to many of the agency's multi-billion-dollar endeavors, is vitally important. And NASA has been doing an exemplary job standing up in office and managing the nation's and world's only survey for potentially hazardous Earth-crossing asteroids and comets. I find it distressing that other nations haven't to date taken a more active role, and I note that we have some visitors from Germany here today, and we're very grateful for their interest. NASA began the NEO survey called the Space Guard program in 1998, and I note that my colleague Dana Rohrbacher is here and was instrumental in advocating that, with the goal of detecting and cataloging 90% of all potentially hazardous asteroids and comets larger than 1 kilometer in diameter within a decade. And it appears to be relatively on track to meet that target. Subsequently, a 2003 NASA-chartered team of scientists recommended that the survey seek all NEOs of 140 meters in diameter or larger, reasoning that the smallest of these could still inflict large regional impacts if they struck the Earth. Their recommendations were made part of the 2005 NASA authorization legislation, directing NASA to, in quote, plan, develop, and implement a near-Earth object survey program to detect, track, catalog, and categorize near-Earth objects equal to or greater than 140 meters in diameter, end of quote. The goal was to get 90% completion within 15 years. This change in mission is no small matter, as the universe of potentially hazardous objects, PHOs, to be detected and cataloged increased by a factor of 20, from 1,000 to approximately 20,000. The bill also required NASA to complete an analysis of alternatives to meet this ambitious goal and to report back with a recommended option. NASA provided such a report earlier this year but did not indicate a preferred choice, instead urging the current Space Guard program be allowed to continue its survey for 1 kilometer and larger near-Earth objects and to allow the agency to take advantage of opportunities using potential dual-use telescopes and spacecraft to achieve the goals outlined in the 2005 authorization. Although the 15-year timeline may not be met in all cases, NASA's rationale is purely budget-driven, arguing that current resources are too constrained. While disappointed, I certainly can't disagree or argue with their reasoning. At this morning's hearing, it's my hope that we get a clearer understanding of NASA's plans to proceed with utilizing dual-use telescopes and spacecraft, their potential costs and schedules, and other facilities that may be utilized, including the Arecibo Observatory. I hope to hear concrete steps taken by NASA to develop cooperative relations necessary to ensure the requirements laid out in the 2005 NASA authorization are met. We'll also hear about the future of the Arecibo Radio Observatory in Puerto Rico, the largest and most powerful such facility in the world. Arecibo is operated by the Cornell University under a contract with the National Science Foundation. It appears very likely NSF will significantly reduce its financial support such that Arecibo will have to shut down its radar facility. This, I think, would be a mistake. Arecibo has the capability of making very precise orbital calculations in a short amount of time, a critical feature that optical telescopes simply cannot match. And the sum of money at stake is in the order of several $1 million a year, an investment I think is well worth the return. While NSF may be outside the purview of this subcommittee, the ramifications of Arecibo's loss to the NEO program begs the discussion. I want to first welcome my good friend, Luis Fortuno, to today's hearing. I want to also thank all of our guests and once again express my appreciation for changing their schedule to accommodate our schedule. And I want to thank my chairman, Mr. Udall, and with that, look forward to the discussion.
Thank you, Congressman Feeney. If there are members who wish to submit additional opening statements, your statements will be added to the record. Without objection, so ordered. And in addition, I would also like to include a statement for the record from the Planetary Society in today's hearing. Without objection, so ordered. At this time, I'd like to go ahead and recognize our first panel. And we are delighted to have Representative Luis Fortunio, the Resident Commissioner of Puerto Rico, with us here today, who will be testifying, I think, before the committee for the first time. Congressman Fortunio, the floor is yours.
Thank you, Mr. Chairman. Chairman Ewell, Ranking Member Feeney, distinguished members of this subcommittee. Every day, an enormous quantity of cosmic material falls to the Earth. Most burn up on re-entry in a harmless way. However, NASA predicts that more than 20,000 large, potentially dangerous objects pass by the Earth in close proximity and, given the proper circumstance, could threaten or severely impact our existence. Although the chances of a major impact are slim, the consequences are too great to disregard. I believe we should continue to advance our knowledge of near-Earth objects and the potential consequences for our life on Earth. I commend Congressman Rohrabacher on his effort to continue funding for near-Earth objects surveillance programs. Since 1992, the Space Guard program's goal was to discover 90% of the NEOs with 1 kilometer diameter potential by 2008. Although the success of this program will be substantial, there will still be thousands of objects ranging from 200 to 500 meters in diameter that will be overlooked. We must enhance our understanding of this phenomenon by studying and assessing the threats posed to our environment and to our national security. According to Director Michael Griffin, NASA does not have the funds to carry out a more extensive program. There have been suggestions that NASA and the National Science Foundation should cooperate to fund the construction of a new ground-based telescope to perform tracking functions of near-Earth objects and other astronomy surveys. I do not think we need to take on such a burden, and there is still a great deal of information to be gained by utilizing the unique capabilities of the Arecibo Observatory in Puerto Rico. As the world's largest and most powerful radio telescope, the Arecibo Observatory is essential to monitoring and surveying NEOs. However, the National Science Foundation has threatened to close the observatory in 2011, and NASA has so far been unwilling to assume funding of the radar required for tracking NEOs. Closing the observatory will severely limit our ability to quickly and accurately refine the orbits of newly emerging threats and reduce our monitoring capabilities. This is why I have introduced H.R. 3737, which directs the National Science Foundation and NASA to work together to ensure continued full funding of the Arecibo Observatory, and in particular, the radar. It is my recommendation, and the recommendation of 19 of my colleagues, that these agencies start working in collaboration and reconsider how they allocate their funding. Mr. Chairman and Ranking Member Feeney, the Arecibo Observatory's radar is the world's most powerful instrument for post-discovery characterization and orbital refinement of near-Earth asteroids. The observations performed with the radar are critical for identifying asteroids that might be on a collision course with Earth. I respectfully urge the committee to consider continuing the important work performed by the Arecibo Observatory and consider as well H.R. 3737 as one potential solution to this challenge. The unique capabilities of the radar are critically important as we work towards fulfilling the 2005 Congressional mandate of detecting and characterizing 90% of NEOs down to 140 meters in diameter. A potentially dangerous collision of an asteroid or comet is a very real threat. We must take action now to enhance our awareness to prevent a catastrophe. A better understanding of our skies will not only help us to comprehend the wonders of the Earth environment, but is essential to assessing the dangers that may threaten our society. The world's most sensitive radio radar telescope at Arecibo Observatory must not be closed. By the way, we don't have final numbers, but NSF is determining the exact amount of the cost of dismantling this facility and bringing the area back to a greenfield. But it's around $200 million. We're working on we're dealing with a $4 million gap a year. So the numbers are certainly there as well. Mr. Chairman and Ranking Member Feeney, thank you for the opportunity to provide my views on this issue. I will now ask permission to show in the committee's flat screen some images of the Arecibo Observatory that would help understand the size and magnitude of this extraordinary science resource.
Please proceed, Congressman.
Thank you. That's an aerial picture of the radio telescope. As you see, it's embedded in a number of mountains. That's another angle. It's a massive facility. It really is. It is visited every year by 300,000 people. 25,000 of them are K through 12 students. That's it. Thank you again, Mr. Chairman.
Thank you, Resident Commissioner Fortunio. This testimony has been very helpful, and I want to pay particular note to the costs that might be involved in decommissioning the site. And we look forward to getting firmer numbers, because of the obvious argument would be you could take the money to be used in decommissioning the site and actually operate it for a certain number of years or even decades into the future. At this time, I'd be happy to recognize Mr. Feeney if he has any questions for his colleague, Mr. Fortunio.
Well, thank you, Mr. Chairman, and thank you for your testimony, Congressman. As I read through the materials and the different NSF and NASA projections and discussion of this important issue, all of them suggest that Arecibo is very important to our capabilities. Any decision to close it down seems to be purely budget-driven. And so that I hope as we get the numbers and the estimates for what it would cost and what the impact would be of shutting it down, that you'll immediately provide this committee and also the committee with jurisdiction over NSF with those numbers. Because if this is entirely cost-driven, then we need to, as we're understanding the advantages that everybody acknowledges, we also need to know that the of keeping it open, that the disadvantages of closing it also will have a significant cost, many, many times what it costs on an annual basis to keep it alive. Our next panel includes some very distinguished witnesses. One of them, for example, Mr. Yeoman's testimony will tell us that Arecibo and Goldstone complement one another and provide two very different functions. That's very important, because while the one telescope is capable of identifying near-Earth objects that may be a threat, it is Arecibo that helps us determine the exact threat to the Earth. And the fascinating thing is that we have the capability with Arecibo, at least with the large objects that we've now proceeded to catalog, and we're very near our goal, or at least we're on track. Mr. Yeomans will testify, once we find the vast majority of them, they can be tracked, cataloged, and then ruled out or in as threats during the next 100 years or so. I think the people of the world would be very grateful to know, especially with 100 years' notice, that there may be a catastrophe driven by a near-Earth object. But most importantly, we have the technological capabilities to actually deflect or to eliminate the damage with that type of notice. And again, Mr. Yeomans and our other witnesses will testify to that. So, Mr. Fortunio, I know that Congressman Rohrabacher had a question. I wanted to yield a few minutes to him. But if you could tell us the impact, because probably uniquely you're able to tell us this question, the impact on Puerto Rico if we shut down in the next year or two the Arecibo, what the local impact would be. We'll get to the technical experts. I'd assume that you're not an astrophysicist. Neither am I. Don't feel bad about that. But go ahead and tell us the impact of Puerto Rico.
Thank you. Thank you for your comments. Certainly, the impact, we're estimating that it will be about $50 million for the Arecibo area. Actually, on top of that, the impact on those kids that may have an interest in science and technology that will not be able otherwise to visit a facility like this one. If I may add, the Arecibo radio astronomy led to the first discovery of a planet outside of our own solar system, to the first discovery of a binary pulsar, resulting in a Nobel Prize, and the first detailed three-dimensional mapping of how galaxies are distributed in the universe. So it's really, from the scientific point of view, it will be priceless to our young students that have an interest in this area.
Any remaining time, I'd be pleased to yield to Congressman Rohrabacher.
Oh, thank you very much, and thank you, Mr. Chairman, for your kind words and bipartisan words at hearing. Can't help but notice George Brown's picture right back there. I don't know how many people in this room knew George Brown. I knew him. He was the chairman here when I came here 20 years ago, and he was a wonderful human being, a man of integrity. And I'm very pleased that some of the work that I've done in this area has actually bore the name of George Brown, because he was just a fine person and had that very same bipartisan spirit that Mr. Udall has been trying to demonstrate here today. And hopefully, when we're talking about things that might threaten the entire planet, that may well motivate Congress to be bipartisan if nothing else does. I mean, after all, it's just the entire planet that may be destroyed. So, but George Brown really gave me personal guidance, and his integrity was very much appreciated. When we're talking about Arecibo, I want to, of course, recognize the hard work that Mr. Fortuna, Congressman Fortuna, is putting out in this effort. It's a heroic effort. I'm very pleased to be assisting him. But of course, we're not trying to do anybody any favors here. This isn't an issue of doing anyone a favor. First and foremost, the Arecibo telescope is doing work currently that would cost us more, even outside of the area of near-Earth objects. Even outside the area of near-Earth objects, the Arecibo telescope is doing work that would be more costly to do if, for example, we would send satellites to, and I understand we sent a mission to Venus that cost a certain amount of money, but the actual images that we got back from Arecibo were better than what we did than sending the probe up to Venus. Now, how much did that cost us? I mean, it probably cost us enough to keep Arecibo going for a decade. And clearly also, when you look at the shutdown costs, which has been mentioned here, if you take all of that together, well, you could probably put that in the bank, and the interest on that money would probably keep the Arecibo telescope going. And this exemplifies sort of the screwball nature of the way we do business up here in Capitol Hill sometimes. And if we let this asset be set aside and closed down, it would be a tragedy, but also, as I say, very symbolic of the fact that we can't even do our job in Capitol Hill enough to take a very cost-effective asset and something that's having a mission that's vitally important to our security, that we can't even get ourselves together enough to get a limited amount of money to keep that project going. So I think this is very symbolic, and that we should all be working together on this, and we are working on this. Just a question. Now, you mentioned the kids there, and you mentioned how this would affect your economy. Tell me, if we didn't know that a near-Earth object was coming, and this one snuck by and landed in the Caribbean, would it be possible that Puerto Rico would be wiped out?
Well, actually, anything can happen, but certainly you could have the east coast of the United States, not just the Caribbean, affected by something like that. And again, the cost effectiveness of this facility has to be highlighted. And I thank you, Mr. Rohrabacher, for your leadership on this issue, not just on Arecibo, but the issue in general. I think it's an issue that we need to devote resources and time to it. And I thank the chairman and all the members of this subcommittee.
Shutting down Arecibo means that we are intentionally putting ourselves in a position of ignorance of potential threats.
Indeed.
And with that ignorance may come bliss for a while. However, let us note, it also not only gives us ignorance, but it also prevents us from having any chance of deflection if there is a threat. So we are putting ourselves in a position of being ignorant of a potential threat and also making ourselves incapable of responding to the potential threat. And Arecibo is in the middle of this. No one should take us seriously about watching out for the long-term interests if we let this asset go. So I thank you very much, and looking forward to working with you, working forward with the ranking member, working forward with the chairman. We need to work on this and show that we can actually, if we can't get this done, we can't get anything done. I mean, it's simple as that. So,
thank you.
And thank you for your hard work.
I thank the gentleman from California. I would note for the record that my colleague from Texas, Mr. Lamson, is here. There's nobody more passionate and advocate for NASA and all that NASA does. I do believe he does not have a question for his colleague from Puerto Rico. Resident Commissioner,
I do look forward to visiting, however.
I'm sorry,
I do look forward to visiting the facility sometime.
That's an open offer, I'm sure.
It's a beautiful facility, but actually sometime between December and March is the best time to visit.
And at this time, it seems appropriate to introduce all of the witnesses that have joined us. I would, before I do so, just let the panel know and the others who are here with us that there are votes pending at some point in the next 25 to 30 minutes. I think have a series of at least 2 votes, and we'll do all we can to testimony forward, and then we'll recess 30 minutes and then reconvene the hearing. Let me begin here on my left to the audience's right with Dr. James Green, who's the director of the Planetary Science Division at NASA. Next to him is, moving from left to right again, is Dr. Scott Pace, who's the Associate Administrator of the Office of Program Analysis and Evaluation at NASA. Third on the panel, Dr. Donald Yeomans, who's the manager of the Jet Propulsion Laboratory's Near Earth Object Program Office. Proceeding down the line, Dr. Campbell, Dr. Donald Campbell, who's a professor of astronomy at Cornell University and a former director of the Arecibo Observatory. Next to Dr. Campbell, Dr. J. Anthony Tyson, who's a professor of physics at the University of California, Davis, and a director of the Large Synoptic Survey Telescope Project. And our last witness on the second panel, we have Mr. Russell Rusty Schweikert, former Apollo astronaut, lunar module pilot on Apollo 9, and the chairman and founder of the B612 Foundation. Welcome, gentlemen, to all of you. We're really pleased to have you here today. I think all of you know, I think many of you have been before the committee before, that your spoken testimony is limited to 5 minutes each, after which the members of the subcommittee will have 5 minutes each to ask questions. So, Dr. Green, we'll begin with you. The floor is yours.
Thank you, Mr. Chairman and members of the committee, for the opportunity to present information on NASA's important efforts to find near-Earth objects, or NEOs. At the request of Congress, NASA currently conducts a very successful NEO search program designed to find 90% of the NEOs greater than 1 kilometer in diameter. Since the program started in 1998, NASA has funded over $30 million in NEO search efforts. During this time period, NASA has found, as of Monday, I checked, 727 1 kilometer or larger near-Earth asteroids and 65 Earth-approaching comets, as well as 4,198 smaller NEOs. At the current discovery rate, we will have discovered more than 50 large NEOs by the end of 2008, bringing us very close to achieving our 90% discovery goal, according to our current estimate of roughly 940 greater than 1 kilometer size NEOs. NASA currently funds 4 teams that operate 8 ground-based telescopes of mostly 1 meter class, dedicated to searching the skies and detecting NEOs. All NEO observations that are collected are sent to an international clearinghouse for small bodies. This organization is called the Minor Planet Center. Minor Planet Center determines the initial orbit for any newly discovered NEO, so that observatories worldwide may observe the object and confirm its existence. Once an NEO's orbit has been determined, its potential for impacting the Earth is assessed. Over 99% of the objects discovered by our search efforts so far have no potential for Earth impacts over many millennia, but a smaller number which do are tagged potentially hazardous objects. Now, more detailed and refined analysis of potentially hazardous objects' orbits is then conducted by NASA's NEO Program Office at the Jet Propulsion Laboratory. Observations on potentially hazardous objects are also automatically received, their orbits updated to determine the level of probability of impacting the Earth in the next 100 to 200 years. The results of this analysis is constantly updated and published on our NEO program website. Now, the National Science Foundation's Arecibo radio telescope, although it has no useful role in detecting NEOs, does indeed provide us important observations for NEOs that pass within 20 million miles of the Earth. Arecibo plays that important role in refining the orbit, allowing us to obtain information about the object's size, its shape, and its spin rate. The only other facility currently being used by NASA for routine planetary radar is NASA's own Goldstone facility, which is part of our deep space network. To date, no international facilities are capable of performing this feat on a regular basis. Previous planetary spacecraft missions have not contributed directly to detecting NEOs. NASA missions such as the Near-Earth Asteroid Rendezvous, Stardust, Deep Impact, and the Japanese Hayabusa 1 missions have all brought us fascinating information on NEO composition, origin, and migration into the inner solar system. The recently launched Dawn mission will travel past the orbit of Mars and into the main asteroid belt, observing both Vesta and Ceres, which are the largest objects in that region. The asteroid belt has been shown to be the most probable region where these objects are coming from that we now classify as NEOs. In our report to Congress, requested by the 2005 Act, NASA recommended that the current program be continued and that we would look at opportunities for potential dual-use ground-based telescopes, spacecraft, and also partner with other agencies as feasible. For example, we are actively planning to use the Air Force Panoramic Survey Telescope and Rapid Response System, also referred to as PANSTARS, after it becomes observational with its very first telescope next year. When PANSTARS is completed, and with its intended 4-telescope configuration by 2010, this system alone could discover up to 70% of the potentially hazardous objects larger than 140 meters by 2020. It is important to note that no significant NEO detection efforts are currently conducted outside of NASA. However, there is growing interest in international communities to contribute. Most recently, the United Nations Committee on the Peaceful Uses of Outer Space recently established a working group on NEOs to encourage more international work on the issue. Other opportunities are beginning to materialize. That can help us in these detection efforts. NASA's own Wide Field Infrared Survey Explorer, which is being developed for a late 2009 launch, is an astrophysics mission designed to map the infrared sky. However, it is also capable of detecting many asteroids, in which a portion will indeed be NEOs. We have also been discussing with the Canadian Space Agency how their upcoming NEOSat mission would be able to contribute to NEO research and detection. And other important missions like these are being planned by the European Space Agency, the Japanese Aerospace Exploration Agency, and for which we are in close communications with. In closing, let me again thank you for the opportunity to appear at this hearing, and I would be happy to respond to any of your questions.
Thank you, Dr. Green. Dr. Pace.
Thank you, Mr. Chairman. Members of the committee, thank you for the opportunity. I'd like to review some of the findings and recommendations of the report that we provided to the Congress in response to the Authorization Act of 2005. The principal findings of the report to Congress were the result of a study led by my office. The study team conducted an analysis of alternatives with inputs from several government agencies, international organizations, and representatives of private organizations. I think that we covered a wide spectrum of views of the scientific and technical community in the effort. NASA recommended that the existing Space Guard survey program continue as currently planned. NASA would also take advantage of opportunities using potential telescopes, such as the Large Synoptic Survey Telescope and the proposed Panoramic Survey Telescope, otherwise known as PAN-STARRS, which you heard mentioned, along with potential dual-use spacecrafts and partnerships with other agencies as feasible to make progress toward achieving the legislated goal. However, I have to say that due to budget constraints, NASA cannot initiate a new program beyond Space Guard at this time. And however, as also was noted, that NASA is fair to say would be pleased to implement a more aggressive near-Earth object program if, in fact, so directed by the President and Congress. Given the constrained resources and strategic objectives that the agency has already been tasked with, I have to say that NASA cannot place a new NEO program above current scientific and exploration missions. But I imagine that will be the subject of dialogue and discussion with you and see how we can move forward. The goal of finding 90% of potentially hazardous objects, 140 meters in diameter and larger, is 1 to 2 orders of magnitude more technically challenging than the existing Space Guard mission. To reach the goal within 10 to 15 years would require at least one new dedicated ground or space observatory. And we can share with other folks, but to really hit the goal, you need a dedicated facility. Cataloging the number of total objects, say 100,000 at the rate they'd be discovered, around 30 to 50 a day, would require a new tracking and data management infrastructure whose ongoing operation may constitute a sizable portion of the total cost. A delay of 5 to 10 years in achieving the legislation goal, we think carries little additional risk when the impact interval for 140-meter objects is about once every 5,000 years. We think there is time to do the survey right. This rate of impact indicates the system may need to operate, conducting searches, tracking objects, for an extended period of time before identifying a credible threat. And I'd like to describe really 3 periods in that process. Today, we know where a few 140-meter objects are, but we know little about when or if they will impact. We are ignorant. For the initial 10 to 20 years the survey is progressing, the average warning time will rise, the unwarned impact risk will gradually decline, and during this period, potentially decades of warning will become likely. After 10 to 20 years of a survey, a steady state period will be reached where unwarned impacts of potentially hazardous objects would be highly unlikely. That is, centuries of warning time become possible in a steady state period. The NASA identified in its report an exemplar NEO survey program with estimates for its architectural costs that, if funded, could achieve the specified goal of surveying 90% of potentially hazardous objects by the end of 2020. This would occur by constructing or funding a dedicated survey asset combined with NASA partnerships with other agencies on future optical ground-based observatories. Details of the exemplar program were provided in our report, and again, we'd be happy to discuss them. I want to caution, however, that the budget estimates in the report are what we call architecture costs, and a lot more rigorous analysis would be needed before a program can be assessed for implementation. So more work needs to be done on those cost estimates. Finally, the current NEO Safeguard Survey Program, really without any augmentation, would not be able to satisfy the requirements of the Authorization Act. The Act right now, the requirements of the survey program are to find only NEOs greater than 1 kilometer in diameter. And therefore, if we focused on things smaller than that, 140 meters, would require additional effort. Without major augmentation, NASA estimates that we could detect 14% of the 140-meter or larger potentially hazardous objects by 2020. In our cooperative efforts with Air Force, the PAN-STARRS program, so that it would be capable of providing data on NEO detections after operations start. We think that this system alone could discover about 70% of potentially hazardous objects larger than 140 meters by 2020. So we think there's some promising approaches. While NASA does not have any formal responsibility for the task of NEO mitigation, as mentioned, scientific missions such as Deep Impact and Dawn provide information that may be critical to planning and asteroid deflection. And likewise, many of the systems and technologies that are being developed for exploration are directly applicable to mitigation missions. These capabilities are the hallmarks of a robust and spacefaring nation capable of many tasks that may be assigned to it. Thank you, Mr. Chairman. I'd be pleased to respond to any questions.
Thank you, Dr. Pace. Dr. Yeomans.
Opportunity to appear today.
Dr. Yeomans, I think you should turn on your microphone if you can.
Thank you for the opportunity to appear today to discuss the potential threats of near-Earth objects. Our progress toward meeting the discovery goal articulated in the NASA Authorization Act of 2005, the role of the Arecibo planetary radar within the near-Earth object program, and the response options available if a near-Earth object is found to be on an Earth-threatening trajectory. Near-Earth objects are comets and asteroids that can pass within about 45 million kilometers of the Earth's orbit. While some showy naked-eye comets may occasionally pass close to Earth, it is the difficult to find but far more numerous asteroids that are of the most concern in near-Earth space today. About 1/5 of the near-Earth asteroids can approach the Earth's orbit even closer, to within 7.5 million kilometers, and these so-called potentially hazardous asteroids are of most concern for near-term hazard avoidance. As part of the NASA Authorization Act of 2005, NASA was asked to consider options for extending the search down to objects as small as 140 meters in diameter and to find and catalog them within 15 years of the Act becoming law. By finding and cataloging 90% of this population of potentially hazardous asteroids, the statistical or actuarial risk to Earth from potentially hazardous asteroids of all sizes would be reduced by 99% from pre-survey levels. We can speak of risk reduction in this case because once an object is discovered and cataloged, its future motion can accurately be predicted, and in the unlikely case where it does threaten Earth, there would be sufficient time to deflect it, thus saving the enormous costs due to fatalities and/or infrastructure damage. According to a 2003 NASA Near-Earth Object Science Definition Team study that undertook a cost-benefit analysis for the discovery of potentially hazardous asteroids, the risk reduction accruing from this next-generation potentially hazardous asteroid search would pay for itself in the first year of operations. While an impact by a 140-meter-sized object would not generate global physical consequences, its impact energy would still be about 100 megatons of TNT explosives, and the likelihood of one of these impacts is 100 times greater than an impact by one of the less numerous 1-kilometer-sized potentially hazardous asteroids. With regard to the uncertainty associated with threats from potentially hazardous asteroids, the largest factor by far is the large number of undiscovered objects in the size ranges that are small enough to be very numerous, yet large enough to easily penetrate the Earth's atmosphere. For example, we have only discovered about 4% of the 20,000 potentially hazardous asteroids larger than 140 meters and less than 1% of the 200,000 objects larger than 50 meters. The solution to this uncertainty is to continue and hopefully accelerate the search for potentially hazardous asteroids. Once we find the vast majority of them, they can be tracked, cataloged, and then ruled out or in as threats during the next 100 years or so. The current NASA Near-Earth Object goal is focused upon the discovery and tracking of objects 1 kilometer in diameter and larger. It is not realistic to expect the current survey program with its modestly sized telescopes to efficiently find the 140-meter-sized objects that are nearly 50 times fainter compared to the 1-kilometer-sized objects at the same distance and with the same reflectivity. Because all potentially hazardous asteroids do eventually come very close to the Earth, the current ongoing surveys could complete the goal outlined in the 2005 NASA Authorization Act, but it would likely take over a century to do so. We simply cannot afford to wait that long. At least 2 next-generation ground-based wide-field search telescope surveys are in development. Pan-STARRS is under development at the University of Hawaii with Air Force funding, and will have one of its 1.8 meter telescopes operational in Hawaii in early 2008. It If the planned 4-telescope version of Pan-STARRS is completed by 2010, it could help reach the goal by about 2040. Likewise, the 8.4-meter aperture LSST telescope that is under development with funding from NSF, DOE, and other partners could help reach the goal by about 2034 if it began operation in 2014. If we assume that both Pan-STARRS 4-telescope system and the LSST operate in their planned shared mode, which includes many observations unrelated to potentially hazardous asteroids, then the goal could be reached by about 2026. The potentially hazardous asteroid discovery rate could be increased beyond the results shown in the NASA report if the observing times and sequences of Pan-STARRS and LSST were optimized for potentially hazardous asteroid observations. Most positional data for potentially hazardous asteroid orbit determination and trajectory predictions are based upon optical plane of sky observations. Because the radars provide line of sight velocity and range information to about 1 millimeter per second and 10-meter accuracy levels, these data, when used in conjunction with the optical data, provide a secure orbit and trajectory far more rapidly than if only optical data are available. With only a limited amount of optical data to work with, the orbit of a newly discovered potentially hazardous asteroid is often not accurate enough to immediately rule out a future Earth impact. However, with radar data in hand, the orbit of a newly discovered potentially hazardous asteroid can be quickly and more precisely determined, its motion accurately projected far into the future, and future impact possibilities can usually be quickly ruled out. Likewise, in the rare situation when an object is actually on an Earth impacting trajectory, radar observations will be critical in quickly identifying this case. A number of existing technologies can deflect an Earth-threatening asteroid if there is time. The primary goal of the potentially hazardous asteroid survey programs is to discover them early and provide the necessary time. An asteroid that is predicted to hit Earth would require a change in its velocity of only 3 millimeters per second if this impulse were applied 20 years in advance of the impact itself. The key to a successful deflection is having sufficient time to carry it out, whether it is the slow, gentle drag of a gravity tractor or the more impulsive shove from an impacting spacecraft or explosive device. In either case, a verification process would be required to ensure the deflection maneuver was successful and to ensure the object's subsequent motion would not put it on yet another Earth-impacting trajectory. While suitable deflection technologies exist, none of them can be effective if we are taken by surprise. It is the aggressive survey efforts and robust radar systems that must ensure that the vast majority of potentially hazardous objects are discovered and tracked well in advance of any Earth-threatening encounters. The first 3 steps in any asteroid mitigation process are find them early, and find them early. Thank you.
Thank you, Dr. Yeomans. You all heard the bells ringing. The one vote has been called on the floor of the House, so we're going to continue the hearing. Congressman Lamson will come back and relieve me so we can make best use of your time and the committee's time. So, thank you, Dr. Yeomans. We'll move to Dr. Campbell. Looking forward to your testimony, sir.
Chairman and members of the committee, thank you for this opportunity to address you on the role of radar, and specifically the radar system on the giant Arecibo telescope in Puerto Rico in the tracking and characterization of NEOs and the current state of funding of this planetary National Science Foundation facility. Dr. Yeomans has just described the importance of precision radar measurements in predicting the future orbits of NEOs and determining which NEOs are really hazardous to Earth. For these hazardous objects, additional precision radar measurements are extremely important to assess the impact probability and the need to take action to mitigate the threat. Near-Earth asteroids form a very diverse population encompassing a large range of sizes, shapes, rotation states, densities, internal structure, and binary nature. It is important to understand the range of these characteristics in order to design suitable mitigation strategies. While a very small number of NEOs have been visited by spacecraft, radar provides by far the best means to survey these characteristics for a large number of objects. For an object that we know poses a direct threat to Earth, radar can provide vital input to mitigation planning. As you've heard, there are only 2 very high-powered radars in the world capable of studying solar system bodies, including NEOs. One is on the NSF's Arecibo telescope, and the other is on NASA's Deep Space Network 70-meter antenna in California. The Arecibo radar is over 20 times more sensitive than the one on the Goldstone antenna and has been the dominant contributor to near-Earth asteroid characterization and orbit prediction. However, Goldstone can look at more of the sky than Arecibo, making the two systems very complementary. They should both be preserved. In 2005 and 6, the NSF Division of Astronomical Sciences undertook a senior review to examine the balance of its investments in the various astronomical facilities that the division supports, including the Cornell University-based National Astronomy and Ionosphere Center, which operates the Arecibo Observatory for the NSF. The report was submitted to the NSF in November 2006. Despite considerable input to the committee from both the National Astronomy and Ionosphere Center and the planetary community, the Arecibo Planetary NEO radar program was essentially ignored in the committee's report. The report recommended that NEIC's operating funds provided by the NSF's Division of Astronomical Sciences be reduced over the following 3 years from approximately $10.5 million to $8 million, and then in FY 2011 be halved again to $4 million. At the $8 million level, budgetary pressures are likely to make the termination of the radar and NEO program unavoidable unless additional funding is found. In the slightly longer term, if Cornell cannot find the additional funding needed to keep the observatory open, then in the report's words, the senior review recommends closure after 2011 if the necessary support is not forthcoming. If the Arecibo radar system is decommissioned, it would leave the lower sensitivity NASA Goldstone system as the only radar in the world capable of precise orbit determination for NEOs and measurements characterizing their physical properties. It will probably be unable to fill the void, especially with the large number of NEOs likely to be detected over the next decade or more. Replacing the Arecibo telescope and radar system with a mission-specific facility of equal sensitivity would cost several $100 million. Given his contributions to the NEO program and other research areas and the relatively small budget needed to keep it operating, closing Arecibo does not make sense. In answer to the question as to how much it would cost to support Arecibo for NEO activities independent of any other use of the telescope, the budget would probably need to be very roughly the same as the observatory's current budget, about $10 million per year. Most of the operating costs of large telescopes are fixed costs relating to such things as maintenance, independent of the science mission. In summary, Earth-based radar provides critical information related to NEO orbit prediction and characterization. Arecibo is the primary radar involved in this activity and will remain so for at least the next 10 years, provided that both the observatory and its radar system are adequately funded. If the Arecibo Observatory is closed, a unique research capability will be lost that makes valuable contributions not only to the study of near-Earth objects, but in other areas of astronomy and atmospheric science. One of Puerto Rico's main research facilities and a spectacular structure, as you saw earlier, the Arecibo telescope is important to local education and tourism. Its closing would be a major loss to both science and the island. Thank you for your attention.
Thank you, Dr. Campbell. Next on the panel is Dr. Tyson, and I would, as a preface to his remarks, mention that as a member of the Armed Services Committee, I'm used to many, many acronyms, and I used one earlier in my comments to begin the hearing about the LSST, which is the Large Synoptic Survey Telescope Project, and Dr. Tyson is a key part of that effort. So, Dr. Tyson, welcome, and the floor is yours.
Thank you, Mr. Chairman, members of the committee. It's an honor to be asked to testify before you today on this important subject. The House Committee on Science has been a leader in bipartisan basis over the 2 decades in focusing attention on the need to detect, characterize, and catalog near-Earth asteroids. The passage of the George E. Brown Near-Earth Object Survey Act was a landmark piece of legislation that sets a goal of cataloging 90% of NEOs of 140 meters in diameter and larger within 15 years. The committee is properly looking at the existing and future capabilities of carrying out this goal and expanding the existing Space Guard program. LSST adopted the goal of surveying NEOs at the outset as one of its major science capabilities. I have attached to the statement a 9-page summary of the capabilities of LSST for detecting NEOs and obtaining their orbits. Until recently, the discussion of risk associated with an impact of NEOs has been statistical. In other words, what is the probability? This is similar to considerations of risk in many other areas, such as weather and traffic accidents. What if it were feasible to deploy a system that would alert me of an impending traffic accident well in advance? That would change the very nature of that risk from a probabilistic worry to a deterministic, actionable situation. The ability to detect virtually every potentially hazardous near-Earth object and determine its orbit with precision transforms that statistical threat into a deterministic prediction. We face many threats, and virtually all of them are either so complex or unpredictable that they are treated probabilistically, even though the social and financial consequences are legion. With a comparatively small investment, the NEO risk can be transformed from a probabilistic one to a deterministic one, enabling mitigation. Ground-based optical surveys are the most cost-effective tool for comprehensive NEO detection, determination of their orbits, and subsequent tracking. Radar, as we have heard, also plays an important role once the threatening NEO has been found in refining its orbit when the NEO is near. The first job is to find the NEOs which are potentially hazardous, so-called potentially hazardous objects, or potentially hazardous asteroids, actually, from among the swarm of 10 million other asteroids. A survey capable of extending these tasks to NEOs with diameters as small as 140 meters, as mandated by Congress, requires a large telescope, a large camera, and a sophisticated data acquisition, processing, and dissemination system. This congressional mandate drives the requirement for an 8-meter class telescope with a 3,000 megapixel camera and a sophisticated and robust data processing system. These requirements are met by the LSST. The LSST is currently by far the most ambitious proposed survey of the sky, with initial funding from the National Science Foundation, Department of Energy, laboratories, and private sponsors. The design and development efforts are well underway at many institutions. Fortunately, the same hardware and software requirements are driven by science unrelated to NEOs. LSST reaches the threshold where different science drivers and therefore different agencies, NSF, DOE, and NASA, can work together to efficiently achieve seemingly disjoint but deeply connected goals. This broad range of science has earned LSST the endorsement of a number of committees commissioned by the National Academy of Sciences. Because of this synergy, the congressional mandate can be reached at only a fraction of the cost of a mission dedicated exclusively to NEO search. We have carried out over 100 computer simulations of the LSST operations for a variety of NEO-optimized scenarios. The planned LSST baseline survey cadence on the sky, that is to say the way you tile the sky with time during the night, is capable of providing orbits for 82% of potentially hazardous asteroids larger than 140 meters after 10 years of operation, and is 90% complete for objects larger than 230 meters. This baseline cadence assumes that 5% of the total observing time is spent on NEO specialized observing. This is what is currently planned. By increasing this fraction of NEO specialized surveying to 15%, that is to say from 5 to 15%, and by running the survey longer, the congressional mandate of 90% completeness for potentially hazardous asteroids of 140 meters and greater size can be fulfilled after 12 years of operation, with 60% completeness level reached after only 3 years. These specialized observations would be of limited use to other science programs, and they require 15% of the observing time. The current cost estimate for LSST in 2006 dollars is $389 million for construction and $37 million per year for operations. For a 12-year-long survey, 15% of this total cost is $125 million. Thus, we could deliver the performance of a full NEO-dedicated LSST to NASA and to the world at a small fraction of the total cost to build and operate such a system. This cost is equivalent to 30% of operations, which would commence in 2014. Note that by operating LSST in this special NEO optimized mode, we would have the performance equivalent of an LSST fully dedicated to NEO surveying. By supporting only 15% of the total cost, NASA would be essentially getting an NEO dedicated LSST. This is a key new insight relative to the costing model in the 2007 NASA NEO report to Congress. Thank you.
Thank you, Dr. Tyson. Mr. Schweikert.
Yes, Mr. Chairman, Mr. Ranking Member Feeney, and members of the committee, Mr. Lampson, I thank you for giving me the opportunity here to testify on the near-Earth object situation, on NASA's report to Congress on the matter, and on where we need to go from here. With very limited time, I'll jump right into the 4 questions I was asked to address and our 6 specific recommendations pertaining to it. We were asked first to provide our perspectives on NASA's report to Congress and whether we agree or disagree with the report's findings and recommendations. The first 2 elements of the Congress's directive related to analyzing ways of meeting the new goal, as we've heard, and a specific directive to recommend a program and a budget to support it. NASA completely ignored Congress's direction to recommend a search program and supporting budget. I want to emphasize here, picking up on Chairman Udall's earlier comment, that not only did the Congress direct NASA to do to make a recommendation and a budget to support it, but the President signed that into law. So it is in law by both the President and the Congress. So our first recommendation is that Congress should again direct NASA in the clearest language possible to comply with the law and recommend a search program and supporting budget. With regard to Congress's directive, the third task of NASA, that they analyze possible alternatives that could be employed to divert an object on a likely collision course with Earth, we highlight only 2 of the many technical flaws in NASA's report to Congress. The first of those, NASA misinterpreted the congressional intent and elected to consider for deflection, to look at what would be required, only a set of very large, very improbable near-Earth objects, rather than the far more frequent but still devastating impacts which we are much more likely to encounter. Assuming, therefore, this extraordinary demand, NASA naturally came up with an extraordinary response, namely the use of nuclear explosives. In fact, 99% of the NEOs most likely to trigger a call for deflection can be diverted by non-nuclear kinetic impacts, that is, simply running into the near-Earth object with a spacecraft, similar to what was done by NASA on July 4, 2005 in the Deep Impact crash into Comet Tempel 1. In a letter clarifying the congressional intent, Congressman Dana Rohrabacher stated that, quote, "The first order of business is to ensure that we have a clear understanding of what the options are for the situations we are most likely to encounter," close quote. When shown this letter, NASA's comment to us in a June 18, 2007 meeting was, to paraphrase it, quote, "If we'd seen this letter at the time we began the study, we might have come out with a different report," close quote. Bottom line, nukes are not necessary except in extremely rare and unusual circumstances. The second serious flaw in NASA's report is that NASA failed to understand and address the fact that whenever an asteroid passes near the Earth, for example, as the result of a deflection, it passes through a region in which are scattered hundreds of impact keyholes, small areas through which, if the asteroid passes, it will return in a few years to impact the Earth. Any deflection which causes an impacting asteroid to avoid hitting the Earth will end up instead passing through this minefield of impact keyholes. A successful deflection, therefore, depends upon the use of both a primary deflection, that is, to miss the Earth, using an appropriate impulsive technique, that is, a kinetic impact or, in exceptional cases, a nuclear explosion, and a potential secondary deflection, if it's headed for a keyhole, using a slow push capability to ensure that the NEO both misses the Earth and misses the keyholes, therefore avoiding placing it on a return trajectory with an impact in a few years. Again, in our meeting on June 18, 2007 with NASA, they acknowledged that at the time the analysis was done, it did not understand the importance of this issue. Bottom line, both strength and precision are necessary for a successful deflection. Moving on, the second question I was asked to address was which relevant factors, data, or options are not addressed in the report, and how should NASA investigate those areas? Given the two serious flaws in NASA's report, which I just cited, as well as many others that are outlined in detail in my written testimony, we recommend, number 2, that NASA should produce a supplement to its report to Congress based on new knowledge which has come to light since it began its analysis. The third question Congress asked me to respond to was, what does NASA need to do now to understand and mitigate the risks of potential NEO impacts? Absent someone in NASA going beyond the search and discovery challenge and thinking through the complex issues of NEO deflection, we stand justly accused of focusing on numeric goals for the sake of meeting an abstract quota, that is 90% of so many objects, etc., etc. We therefore recommend that NASA, our third recommendation, that NASA should assign someone in its NEO program to the specific task of thinking through, analyzing, and understanding the NEO deflection challenge. And in addition, our fourth recommendation, based on this question, is that NASA should validate the basic NEO deflection capability through the execution of a demonstration asteroid deflection mission. That is, we should not be put in the position of doing a deflection mission for the first time when lives actually count on it. Finally, we were asked what governance structures should be established to address potential NEO threats. This is by far the most important question that I was asked by the Congress. NASA, as the U.S. and arguably the world's premier space agency, should have the responsibility for both fully understanding the NEO deflection challenge and developing and testing deflection technology. It does not have that responsibility now. Therefore, our fifth recommendation, is that the Congress expressly assign to NASA the technical development elements of protecting the Earth from NEO impacts as a public safety responsibility. That is, without NASA having the specific responsibility assigned to it to develop the technical means of protecting the Earth from NEO impacts, it will not be done. They must be assigned this responsibility. Otherwise, there will not be action in this regard. The larger question, however, is to which agency of government should the overall responsibility for protecting the Earth from NEO impacts be assigned? Not just the technical development aspects, but the policy and political responsibility. This inherently international issue will involve complex and very sensitive coordination and negotiation, and the U.S. involvement will place in the hands of the agency responsible the lives and property of potentially the entire population. We therefore recommend as our final and sixth recommendation that the Congress study the issue of overall governmental responsibility for protection of the Earth from NEO impacts perhaps with the assistance of specialized policy entities, and ultimately to hold public hearings to engage a wide perspective on this issue. The logical candidates, obviously, for this overall responsibility are the Department of Homeland Security, the Department of Defense, and of course NASA itself. This has been of necessity a very cursory review of a very important set of issues and questions. I thank you for the opportunity to discuss them with you, and I look forward to responding to any questions you may have.
Thank you, sir, very much. Thank all of you, the whole panel. It's again, a pretty fascinating topic for us to be taking up. At this time, each member will be given 5 minutes to question the panel, and I will yield myself as chairman the first 5 minutes. And Dr. Yeomans, is it correct that that you pretty much agree with the importance of surveying all potentially hazardous objects down to 140 meters in size?
Yes, I think that's the next step. By doing so, by finding 90% of these objects, we would effectively reduce the risk of all near-Earth objects to Earth by 99%. Now, Rusty mentioned the smaller objects still, but I mean, that could be the subject of a third-generation search. But the 140-meter and larger objects are primarily necessarily the focus of the next survey.
Well, the Authorization Act of 2005 directs NASA to implement a program to catalog that 90% of all the 140-meter or larger NEOs by the end of 2020. Is that still a realistic goal, or should the scope or timetable be adjusted? And if so, what would you recommend that new goal to be?
Well, I think the 2020 timeline was selected because we needed some sort of a metric to judge progress by, but it's been pointed out that the impact interval for a 140-meter sized object is about 5,000 years. So my personal opinion would be that we could afford to wait another couple of years and perhaps do the survey by the end of 2030 or thereabouts, and explore some options that would be easier and less expensive to carry out within that time frame.
Maybe our technology even will have grown more and we'll be able to do it more effectively or at a lesser cost. Dr. Tyson indicates that the LSST could meet the 90% goal by 2026 at an average cost to NASA of about $10 million a year for 12 years. From a risk reduction standpoint, how serious would 6-year delay meeting that congressional goal be? And would anybody else after that, after your comment, would anybody else like to make a comment on it?
I think that the risk reduction is significant if one is able to go down to these small sizes in 12 years as opposed to 10 years. My personal opinion is the same as Don's. I think that one has to just get on with it and do these surveys. And if it takes 12 years instead of 10 years to reach 90%, then we should do that.
Dr. Yeomans, would you comment also, please?
Yeah, I agree with what Tony said. I would like to see perhaps an extension of our report to Congress whereby a few options are looked at in far more detail in a more rigorous fashion, and costing is done in a more rigorous fashion, and perhaps one of the options, one of the few options that would be examined would be the LSST working in cooperation with PanSTARRS, and also one, perhaps two space-based options. Infrared surveys are still very effective, but that would be my suggestion.
Anybody else want to make a comment on it before I ask my next question? Okay, let me go on because we're going to get to all of you. Dr. Yeomans, what, if any, contributions are non-U.S. organizations or agencies providing to the direction, tracking, or characterization of NEOs?
Well, as was pointed out, in terms of discovering them, NASA is doing the lion's share of the work. Certainly more than 98% of all discoveries are by NASA-supported facilities. But there are international efforts underway to characterize these objects. Our colleagues in ESA, the European Space Agency, are making strides. Japanese have a mission currently underway to visit a near-Earth asteroid and bring a sample back, so that's important. We have a group at Pisa, Italy, that's also working with us very closely to determine independently impact probabilities for various objects, and so we are constantly in touch with those folks to verify our results, and they're doing the same and verifying their results with us. And if we come up with interesting objects like Apophis, for example, the object that will get very close to the Earth in 2029, we wait until we have verified our results with our colleagues in Italy before we make any formal announcements. So that's working very well.
Is there more that should be done? So what steps ought to be being taken? Can we build greater relationships? Obviously through science we can, but is this one of those areas?
I think it is. We should continue to encourage our international colleagues to participate more in the discovery area, more in the characterization area, and those activities are ongoing through the action team that was mentioned, the UN Action Team 14 for the Committee on Peaceful Uses of Outer Space. So that those international discussions are going on. We certainly would appreciate more international efforts in these areas.
Dr. Green, what, if any, plans does NASA have to engage other nations or international entities in efforts to direct and characterize NEOs?
Currently, through our bilateral discussions with many of the other space agencies, such as ESA, such as the Canadian Space Agency, this is indeed a topic that comes up on every agenda. And indeed, we do see, as I mentioned in my testimony, growing international interest in this area. There are several missions that ESA has been studying, and most recently in what they call Cosmic Visions is another mission called Marco Polo that does have a much better chance now of making it through their budgetary process that will also add information that's important for us. The Canadians will be launching a spacecraft called NEOSat. We've been discussing about how it can be utilized and making the data more available. So indeed, in summary, that interest now is becoming more international. It is getting into the plans, future plans of our space agency partners. And as I mentioned, it is indeed a topic that we will continue to discuss and promote.
Anyone else, Mr. Schweikert?
Yes, Mr. Lamson. Let me simply second what has been said, but go a bit beyond it. I think that one of the most important things that can come out of this hearing is to explicitly recognize that what we're discussing here is not science. What we're talking about here is public safety. This is not a subject in which relatively small amounts of money, frankly, should be traded off with the scientific research that goes on in NASA and elsewhere. We're talking here about two separate things, and they should not be mingled and seen as a zero-sum game, which is the way in which expenditures for issues related to near-Earth objects are seen by many people today. This is not a zero-sum game. We're talking about two things. One is science and exploration. Another is public safety. And we should not sacrifice public safety for science. These things are very important. I think when you go to the international community for additional support, it would be very helpful if the U.S. in its presentations in COPUOS in the United Nations were to appeal for additional support on the basis that we are talking about public safety on a worldwide basis. I think that may make a real difference. Thank you.
Thank you very much for your comments. Anyone else? Thank you very much. I will yield the next 5 minutes to Mr. Feeney, Ranking Member.
Well, thank you, Mr. Chairman, and I'm struck by your remark, Mr. Schweikert, that the way to appeal for international support on this is through the safety and security, and I happen to agree with that. I mean, a lot of exploration, especially space exploration, is just not a zero-sum game, but there are winners and losers. There are property rights issues. There are capabilities in terms of geopolitics, but certainly when you're talking about the potential to deflect a threat to the entire Earth, it seems to me that had the dinosaurs had the capability to deflect, these things 65 million years ago, they might still be around. And maybe we can convince some of our international partners to bear some of the load, because there really is, this is a win-win for everybody involved. So, because there's so many fascinating parts of this, Dr. Yeomans, you stated in your remarks did not specifically talk about the technology that Mr. Schweikert did. You said that existing technologies can deflect a Earth-threatening asteroid if there is time. Can you describe those technologies, and can you give us your assessment of Mr. Schweikert's discussion of nuclear versus kinetic and the size of the objects?
Well, there's basically two groups of mitigation techniques. There's the fast flyby or impacting techniques. You run into it as we did with the Deep Impact mission back in July of 2005, and simply slow the object down if it's small enough to do that, and you have time enough so that in 20 or 30 years' time, when it was predicted to hit the Earth, its orbit would have been changed so that it wouldn't hit. So there's the fast or impulsive techniques where you run into it, or if it's a large object, you would use nuclear explosives perhaps. And then there's the slow push techniques where you rendezvous with the object, fly alongside it, and you do a number of techniques. Possibly a gravity tug has been suggested, where you just take your spacecraft and put it up next to your asteroid and just use the gravitational attraction between the two to move them just a little bit. Now, that's a technique that, as Rusty pointed out, can be used for so-called trim maneuvers. That's not what you would do primarily, but you would use that as a secondary device to alter the orbit of the object in the event that your primary technique, the impulsive technique, perhaps didn't do the job or knocked it into one of these subsequent keyholes that he talked about, where a subsequent impact would be likely. So in any event, you need a spacecraft nearby to verify the result. That's clear. So, or that would be the optimal technique. So again, you have to find them early to allow that to happen.
Yeah, Mr. Schweikert, staying on the deflection capabilities for a second, you said, NASA says the slow push mitigation techniques are the most expensive, and we're furthest behind in technological capabilities. You seem to have a very different view from NASA's preference for a nuclear device. In terms of whether we use the slow push or versus nuclear, in terms of where we could intercept a near-Earth object, is there a difference in terms of, when we can intercept the object in the two techniques, and what are the relative advantages and disadvantages depending on size of the NEO?
Yes, thank you very much for the question. First, let me endorse everything that Don just said in response to your earlier question. I don't think we have any daylight between us, frankly. I think the daylight is between what Don just said and what I also believe and what the NASA report to Congress said. There's quite a bit of difference in there.
Is it fair to say that NASA, they know we have nuclear capabilities, and they know that they had a mission with 1 kilometer NEOs. What they did was to take, the limited number of threats that they knew how to deal with very comfortably, but they avoided the more complex and the more numerous problems. Is that maybe?
Yes, I think that's a fairly good representation. Let me give you an idea that the nuclear, I would not, our organization would not suggest that nuclear can be ruled out. However, statistically, if you look at the probability of needing to use nuclear as opposed to non-nuclear means, that the frequency of that occurrence would become necessary about once every 100,000 years. So you're talking about a very improbable frequency of need, and it is that issue which we have with what appeared in the NASA report. And let me emphasize again that, as I stated in my report, that NASA, in our discussions with them after they submitted their report, acknowledged that they did not fully understand this issue at the time the report was written. Don has now reflected, in fact, a current and I believe a view which we totally support and agree with. Let me go to something which you mentioned, which is an extremely important, let me say, misperception, and that is that in some way what we're talking about is a slow push technique versus nuclear or kinetic impact. The thrust of my, no pun, the thrust of my testimony is to point out that both strength and precision are needed for a successful deflection when an asteroid is headed, let me say, for a direct impact with the Earth. You need the strength of a kinetic impact in general, or under exceptional conditions, a nuclear explosion. But you need to follow that up potentially if, in fact, the deflection has now caused the asteroid to head for a keyhole, which will cause it to come back. You need now this trim capability of the slow technique, gravity tractor or other slow technique, which can make a precision correction to ensure that you don't have that asteroid coming back and hitting. Those two things are necessary for a successful deflection. Now, the one final thing which you mentioned, and we have not addressed it yet, but it's very important, and that is that NASA did not, in completing its report on the deflection capabilities, understand that the precision deflection that we're talking about can be done with existing space hardware. They use for their analysis the assumption of a very large, very complex spacecraft for a gravitational tractor. And that was incorrect. It was a misunderstanding, and in fact, that error should be corrected. Existing ordinary technology can be used. It's very mature, and it is very inexpensive, in fact.
Just very briefly, with my colleagues' indulgence, I'm fascinated by these keyholes, which...
Yes.
Okay, so we're successful with the deflection for the time being. We miss, and it, for whatever reason, it goes into a keyhole. Don't we get a second shot to play ping pong with the thing?
The basic sequence which Don outlined and which we advocate is that first of all, we don't talk about a deflection mission. We should be talking about a deflection campaign, because one of the things that you need to have in place at the asteroid that you intend to deflect is a transponder, a spacecraft that has rendezvoused with it, that has a transponder, so that we can do precise radio tracking. Number one, we need to determine, in fact, is that asteroid headed for an impact with the Earth? Number two, if it is, then you send up a deflection mission, a strong one, a kinetic impact, to make the primary deflection so that it misses the Earth. The next thing you do is go over to it with that same spacecraft, which has now been observing that impact, to again precisely determine the success of that primary deflection. And, very important, is it now going to pass through one of these nearby keyholes? If, and that's improbable, but if it is heading now for a keyhole, then you need to make a small adjustment in the deflection using that same spacecraft with a transponder that has a gravity tractor capability to make a small adjustment to make it miss that keyhole. Now you have missed the Earth and all return keyholes, and therefore you have a successful mission. That's a deflection campaign involving basically two spacecraft.
Mr. Rohrabacher.
Thank you very much, and I have certainly found this hearing to be fascinating, as I expected it to be, and I would hope that we attract enough attention from the general public and from decision makers to understand that there are some things that we have to do. And I certainly agree with Rusty when he suggests that this is a safety issue and not a science issue. I would call it planetary defense, for lack of a better description. And I would hope that as we do enlist others, European allies and the Japanese and others, I would hope that we also include the Russians in this equation as well. No one mentioned the Russians. I think a Russian-American partnership in this endeavor, I think they have a lot to contribute, and I think it would go a long way towards establishing the type of cooperation we need in space with the Russians. And with that said, I see Arecibo, when we talked about, is a short-term issue. What we're talking about here, I mean, Arecibo is step number one, and we got to get that done, and then we are talking about this further threat. Now, I understand that that means we got 15 minutes, so I could be able to finish my questions. That's good. I understand that the object that hit the Earth and now is being credited with eliminating the dinosaurs happened about 65 million years ago, but I understand that they say that an object like that, odds-wise, would be about every 50 million years. So are we not now in a cycle that would put us in the probability that there's another such object that may head to the Earth, not in the near future in terms of our lifetime, but in terms of the lifetime of the planet? Is that accurate to say?
If I may respond, statistically, the likelihood of an object that size happening, first of all, that was a 10-kilometer sized object, and there currently are no potentially hazardous asteroids that are that size. The largest is to Taurus, which is 5.4 kilometers, so we're not likely to see another dinosaur-like event. And then the probabilities are such that could, I mean, an impact of an object of a particular size could happen tomorrow. It could happen in 5,000 years. So they're not really on cycles as such.
Well, but we're just talking about the levels of probability or likelihood, and people chart out what these objects are going. You know, every so many thousand years, you can expect something to happen, just with the likelihood of the objects that are out. I think we're just talking about mathematical likelihood and not necessarily anything else. I'd like to note that just a few years ago there was a near-Earth object that passed between, or at least as close to the Earth as what it would have been between the Earth and the Moon. It was that close, and we didn't actually see it until it was actually passed. And when you talk about Apophis, it's a near-Earth object that, as we say, and I think Rusty mentioned it was 2029 is when it might be coming close to the Earth. Is it true that we do not know if that object will, after it goes past the Earth the first time, that we do not know if the Earth's gravity will actually impact its trajectory to the point that it then becomes a threat? Is that correct?
That's correct. The Apophis will make a close approach on April 13th, 2029. Friday the 13th.
Friday the 13th.
It gets within 4.5 Earth radii of the surface, well within the geosynchronous altitude of our satellites.
So it's actually closer than some of our satellites.
It is.
And we don't know what the Earth's gravity will do to that trajectory. And so it may, 10 years later, we may, as Rusty is talking about a campaign, we may be facing a second onslaught that may be even more dangerous 10 years later.
Well, it has a 1 in 45,000 chance of passing through one of these keyholes that Rusty mentioned and hitting us in April 13th, 2036. But with the help of radar, Arecibo and Goldstone in 2013, we have a 95% chance of eliminating that threat altogether. It's a very unlikely situation, and one that we can drive to zero, probably.
Now, I will tell you that unlikely is, I remember the very first hearing we had on this, and I keep remembering that maybe it was one of you who suggested, the chances of anyone ever being hurt on this planet by a near-Earth object is, about the same chance as you getting a royal straight flush in Las Vegas. And it just happens that I had gone to Las Vegas and got a royal straight flush once. And so that's really actually what made it real for me, was when someone said that. And also now I have 3 children at home that are 3 years and 3.5 years old. We're not just talking about my lifetime or your lifetime. We're talking about their lifetime as well. So I think that Rusty calculated it right. However, let me just note, said, Rusty, that this is, when we're dealing with people, we got to deal with this as a safety issue. It shouldn't be a trade-off for science. That works internationally, maybe, and it may not work in terms of getting the job done here. That may be the only type of trading game that we can do here on Capitol Hill and still get the job done. And this issue has a priority for me. As far as I can see, we need to understand the threat, and that's what we're talking about right now. We don't even fully understand the threat yet. Then we need to know what we should do, which is a matter of discussion, and we have not even come close to that yet. And finally, we need to know who's going to be in charge of doing what needs to be done. Right. And so we need a lot of discussion on this and make those determinations. We are just now at the should we even take the steps necessary to understand the threat stage? And I think there's no question about that.
Yes, I think it's very important, your last point, Congressman Rohrabacher. What we know now is that NASA is responsible, NASA is in charge of discovering, tracking, cataloging, etc., near-Earth objects. What we also know, but we don't seem to acknowledge, is that no one is in charge of protecting the Earth from impacts.
Right.
So that next step is extremely important. At the moment, NASA has not yet adequately thought through the deflection issues. They have not, because they have not been told to. They do not have that responsibility. Until NASA or someone is given the responsibility to think through all of the implications and decisions and international cooperation, etc., for protecting the Earth from impacts, not just finding them. That job will not be done. So this is extremely important.
All right. Mr. Chairman, I would suggest that that's our job, is to make sure, that's our job in Congress, is to designate who is going to be responsible for that, what Rusty was just talking about, and we should do that this session of Congress. That important an issue, and if another near-Earth object sneaks up on us and we don't even know who we're going to, what procedure we're going to use to try to thwart the threat, then we haven't done our job. Thank you very much, and I appreciate you, Mr. Chairman.
Thank you, Mr. Rohrabacher. We, as you all know, have another vote underway. I'm going to recess the committee for a very short period of time, given its one vote, and will return as quickly as I can to continue the questioning. We will have another round. I know Mr. Feeney tends to return. I will see if Mr. Rohrabacher wants to ask another round of questions when we reconvene the committee. So, committee stands in recess.
Yes, both ratings.
I like the way Don has shifted over.
Operating. Yes, this is.
I think that'd be good. So, but as long as it's
Is that okay?
the hearing will reconvene. Again, I want to thank the panel for your forbearance with all the votes. We do, I believe, have another vote in an hour, so I understand that we can probably conclude the hearing in the hour we have left to us. At this time, the chairman will yield himself 5 minutes, and I'd like to focus Dr. Green on the testimony is delivered by you, and Dr. Pace recommends that NASA continue the existing safeguard survey and also take advantage of opportunities using potential dual-use telescopes and spacecraft and partner with other agencies as feasible to make progress toward achieving the legislative goal. We've heard today at least 2 examples of potential partnerships with other agencies supporting the planetary radar at Arecibo and funding the NEO operations of the LSST that would make significant progress toward achieving the legislative goal for NEO detection and tracking at, I believe, a modest annual cost to NASA. What specifically is NASA doing to take advantage of either of these 2 potential partnership opportunities?
Indeed, we do want to continue on with our discussions with NSF for the use of the LSST. We have certainly an infrastructure in place with the Minor Planet Center and our ability to utilize that data for NEO detection and orbit determination. Also, I had mentioned in my testimony the importance of using the PAN-STAR system that the Air Force is currently putting into place, and in fact we've provided them a small amount of funds to be able to upgrade their software such that they are able to do some tracking, which is extremely important, and they've been very receptive, and that relationship is also quite strong. So our intent is indeed to leverage these 2 important facilities as they are available and as they come online.
Thank you, Dr. Green. To follow on, I wanted to ask if you've entered into any concrete discussions with NSF or DOE on potential partnerships addressing this congressionally directed NEO survey task, and if not, why not?
Okay. Indeed, as I mentioned, we have concrete discussions with the Air Force utilizing the PAN-STAR system, and they're fully aware of what our intent is. NSF indeed is aware of our interest in using the LSST, and I anticipate that within this next year that those discussions will become more firm as we do understand how the funding is available for them to be able to actually build that system.
Thank you, Dr. Green. To continue this line of inquiry, you mentioned that you're providing funding to the Air Force for PanSTARRS. Did NASA do an analysis of the relative merits of providing NASA funding for PanSTARRS versus funding for the LSST or the Arecibo Planetary Radar before deciding to give these resources to the Air Force? And if not, why not? And how much money is being provided, and where is it coming from in NASA?
The funding that we are utilizing to support small upgrades in the software for PanSTARRS is a fairly modest amount. I would have to come back to the record to give you the exact amount, but it's within $100,000 to $200,000 range. Indeed, what we have arranged with time has been utilizing the funding for our NEO search opportunities with NSF Arecibo's telescope by allowing us to increase the number of observers on utilizing that facility with time, and then NSF taking over more of the operational activities. And then we're following the National Academy report that did indeed suggest that NSF should support their ground-based facilities, and that allows us to better utilize the funding that we have available.
Is NASA prepared to consider providing funding to Arecibo or the LSST project as is being done with PanSTARRS? Again, if not, why not? And if I can add a comment, why wouldn't it be logical to support those other activities if you're prepared to support PanSTARRS?
Well, currently, our arrangement with NSF has been to follow the NRC report that came out in 2001, which delineate roles and responsibilities for the funding of infrastructure. Indeed, we have worked with NSF in the past to be able to develop Arecibo capability for its radar use, and therefore we leverage that as the rest of the community does for that kind of research. So with respect to that, I believe we have a working relationship is what it boils down to. NSF is funding their infrastructure capability. We're able to, with time, as I mentioned with Arecibo and also with the PanSTARRS system at Air Force, provide incrementally small amounts of funds to be able to meet and satisfy our requirements and needs. And that has worked extremely well, and we will continue to pursue that approach in the future. The LSST activity, of course, is one that needs to be resolved in terms of whether they will have sufficient funding and be able to put together the capability before we can begin to figure out how to work with them and leverage that system.
Dr. Yeomans or anybody else on the panel, would you care to comment?
I'd just like to add that the modest funding to PanSTARRS was done under a peer review process. They submitted a proposal to the Near-Earth Object Observations Program at NASA headquarters, which is a modest program in and of itself. And it was thought that at the time that their proposal was of sufficient merit that it should be awarded this modest sum. So that was the process by which PanSTARRS was funded at a modest level.
Anybody else on the panel would like to comment? Dr. Campbell?
I may. I just, on the Arecibo situation, like to comment that, perhaps the NSF hasn't read the NRC report, but my understanding, they feel very strongly that the solar system research, and especially research related to the NEO issue, is a NASA responsibility, and that they're very reluctant to provide additional funding to carry out that activity once the their plans to reduce to act on the recommendations of the senior review to reduce Arecibo's operating budget to $8 million. In turn, as Green just pointed out, the NASA feels that they shouldn't really be supporting the operations of a National Science Foundation facility, as opposed to supporting some of the scientists who make use of it. What we're talking about here are the operational costs of the radar system.
Dr. Tyson.
Yes, thank you. I'd like to make a couple of comments. First of all, the progress, we're on schedule on LSST towards the first light in 2014. We have a grant already from the National Science Foundation for R&D. We're about 2/3 the way through that. We have put in earlier this year a construction grant, construction proposal to the NSF. We just had that review, very good positive result from that, and we're going towards readiness into the National Science Board. So we're on schedule, actually, for a 2014 first light. What's needed here to address this modified mission beyond what we intend to do, this extra 15% of near-Earth asteroid observing, is some extra support, starting now with the collaborating with the computer science community on new ways of linking the small tracklets that one has when you take multiple images. Each one of these, LSST will see about 150, each one of these small asteroids about 150 times. You have to link all of these little tracks together. The problem is, the challenge is this. I just wish we had special glasses that we could put on when we look out at the night sky and we only see the nearby Earth-threatening asteroids. Unfortunately, when you look out deeply in the night sky for things that are moving, you are confusion limited by this huge cloud of 10 million main belt asteroids, and you actually have to track all of those guys. You actually have to know each one of those orbits in order to separate out the Earth-threatening ones. So that's the challenge, and that takes a lot of millions of lines of computer code. There are some clever computer scientists out there that think they have a solution to some of those problems, and we need to get on with it. That's about $1 million a year starting in next year or the year after, 4 or 5 years, and then we will have the software in place. And then that extra 15% effort would cost us somewhere around $12 million a year during operations. I wanted to make a comment, if I may, about radar versus optical. I think you need both. You need both. One is not the replacement for the other. Radar is not a method of discovering all of these things and winnowing down this 10 million objects into the few that are threatening. But once you have done that with optical, then radar is absolutely critical on the ones that you're really concerned with to refine the orbit.
Yes, Chairman Udall, I'd like to just pick up on where Tony left off and give a slightly different language, perhaps, or perspective on the Arecibo radar and its criticality. As Tony said, these two are not, I mean, the Arecibo radar is not simply another thing to look for asteroids with. Number one, radar is not a good instrument to find or discover to meet the quota that you guys have essentially dumped on NASA, you know, a certain number by a certain year. However, when what you're looking at or thinking about is protecting the Earth from impacts, picture yourself with a few hundred baseballs headed for your head. If you willingly take your pen and poke out one eye, you're now left with monocular vision. You don't have binocular vision. And if you want to get depth perception, you need both eyes. And yet what we're doing is we're about to head into a serious decision-making process over the next 15 years on do we or do we not have to deflect something. And what you've done is, if you eliminate Arecibo, is you've wiped out willingly your binocular vision. Now that is extremely important. It's a little different way of thinking about the essential nature of Arecibo. It complements the optical view. And the most critical decisions we're going to make are the most frequent ones, are the relatively small objects, which are numerous, which we're going to have to make decisions about. Those are the very ones you get the least amount of data on, and where the Arecibo contribution is extremely critical. Because the next time you see that asteroid, it may be on final approach. And that first vision you get of it needs both optical and radar. You need both eyes. So that's a different take on it. But it is not meeting the search goal which NASA has been assigned. It doesn't help in that, but it does help if what you're interested in is protecting the Earth.
Hey, that's very, very helpful to get that perspective. The chair now recognizes, as we begin another round, the ranking member, Mr. Feeney.
Thank you, Mr. Chairman. This first question is for Dr. Tyson, Mr. Schweiker, Dr. Yeomans, and Dr. Campbell. The NASA recommendations are that we survey objects that come within 0.05 AU of Earth's orbit instead of 1.3 AU as required by the 205 authorization. Do you agree or disagree with that recommendation? And why don't you give us some comments? If we need to change our recommendation, we need to. This is a place to start.
Congressman, I do agree with that. If you're calculating, if you're interested in, as I think we are, completeness in a survey of Earth-threatening objects, then you should have a survey of Earth-threatening objects, and those are the ones that come within.
Is 0.05 the number? Yeah. That's a reasonable number.
That's right.
Okay,
I agree with that.
Okay, and no dissension? Okay. To the extent anybody has an opinion, they agree with you, Dr. Tyson. I want to get an idea of the potential ramifications from a strike of Earth. A couple of months ago, we had a 1-meter object strike in Peru, roughly. We think it created about a 13-meter crater. Is that impact, I mean, if I'm looking at a 100-meter object, am I looking at a 1.3 kilometer crater? If I'm looking at a kilometer object, by looking at 13 kilometers, and outside the actual kinetic strike and the damage done by things being broken apart by the actual collision, are there other things like radiation or heat or damages that would impact the environment or humans? This is for anybody who wishes to.
Mr. Feeney, if a relatively easy number is a 100-meter object is about 100 megatons of explosive energy, or picture it as 101 megaton nuclear bombs going off in one place without the radiation, without the nuclear radiation issue. But the explosive force is tremendous. Now, the other effects, I mean, the detailed effects of shock and that sort of thing, or even if there is a crater in the ground, are not as significant. When you talk about an explosion in the low atmosphere equivalent to 100 megatons, the impact on the ground is tremendous. The Tunguska event is thought today to have been about a 5 megaton explosion.
That was in 1908?
1908. We're celebrating the 100th anniversary of that event next year. Celebrating.
We're very familiar with floods and hurricanes in Florida. We refer to things as a 10-year event, a 20-year event, a 100-year event. What was the 1908 event in your estimate? Is that 1 in 5,000 years, 1 in 100?
Well, it's about a 1 in 600 to 800 year event, something like that. The size estimates have recently come down, so the frequency at which it occurs has gone up slightly. But I think the point is that explosion, which flattened 2,000 square kilometers of forest and set them afire in Siberia, luckily it didn't kill anyone, maybe one person, that was only about a 5 megaton event, and it never got to the ground. There's no crater. but the impact would have wiped out all of London or Moscow or Washington, D.C. or any other city had it unfortunately come or exploded over one of those cities. So the impact of these things does not necessitate a crater in the ground, but they're extremely powerful, even down to objects as small as, say, 45 meters in diameter.
Dr. Tyson?
Yes, I'd like to point out that it certainly would ruin my afternoon if one of these things hit close to my house. But most of the Earth's surface is covered by water. And studies of the actual physical damage from objects that are less than about a few hundred meters in size come really from the tidal waves that are set up when these objects would hit the ocean. There's much more danger that all coastal cities would experience a huge tsunami from such objects. The actual physics of what happens with larger objects is different. They are so large, these several kilometer-sized rocks are so large that they actually go down to the bottom all the way through the water and punch a hole into the ocean floor and put all of that mud up into the stratosphere, creating nuclear winter. It's a very different scenario. So for these small objects, it's a different and a somewhat scarier scenario because there's so many more of them. As somebody pointed out, there's a factor of 100 more of these things. And there's a problem with, I have a problem with probability. You can say probably, most likely, you can say that. Well, actually, maybe we should spend $1 million on something else, but because actually the probability of this is rather low. But if a 100-meter object could be on its way towards Earth right now and hit next week, for example, even though the probability per unit time is very low. So I think what we need to do is to get on with these discovery surveys, which find virtually all of the Earth-threatening asteroids and find their orbits, and then it changes the whole equation.
Thank you, Mr. Chairman. I'll yield back.
Thank you. Yeah, I'm not sure, Dr. Tyson, you ruined my afternoon with that image, but that's a very powerful image and very compelling reason to do the work we're talking about here today. The Chairman recognizes the gentleman from California, Mr. Rohrabacher.
Let's see. I think it's going to create a huge wave. I think I'm the only surfer on this panel. Oh, wait a minute, they got another one there. All right. Now let me see if I got this right, Rusty. That the object that exploded over this Tunguska, is it?
Tunguska, yes, sir.
Okay, was only the equivalent of a 5 megaton.
Yes, sir. The most recent analytic work at Los Alamos indicates it was about 5 megatons,
and you're
about
saying,
45
and the ones
meters.
we're looking for are 140 would be the equivalent of 140 megatons if it's a 140 meter object. Is that right? Approximately,
yes, sir.
So you're talking about something that would be 100 times more powerful than the one that Tunguska is what we're just trying to trying to observe.
Sir. That's correct. But let me emphasize, sir, that the 140 meter search goal is in fact at this time the correct goal. Now, because among other things, it's extremely difficult to find things as you get smaller and smaller. So 140 meters is a good goal, sure. And in the process of finding 90% of the 140 meter objects, we're also going to find something on the order of 40 to 50% of the objects down to 45 or 50 meters. Mm-hmm. So we will not have, let me say, a complete survey of those things which can do serious damage on the ground, but we will learn a great deal about them in the process of meeting this appropriate goal.
But we have just, from what you've said, I mean, we're talking about a huge potential destructive power. I mean, we're talking about something beyond, I think, the imagination of any of us here. How many? What is the estimate of the number of undiscovered asteroids that are of 140 meter range? How many have we yet to discover? What are we talking?
Don's probably got the best number, but
the 140-meter sized objects, we think there's approximately 20,000 that are in the category of potentially hazardous asteroids, and we've discovered less than 4% of them.
So there's 20,000. We've actually charted only about 4% of them. And it's 100 times stronger than what it flattened all of that territory up in Russia.
It's like your statements are ignorance is bliss. It will be
yes, sir, Dr. Tyson.
Just to add a data point, it's hard to comprehend the destructive force of something like this, but a 300-meter asteroid, of which there are many, has the potential to wipe out entire countries.
Well, obviously there is a need for us to be prepared to try to do what we could. If we could mitigate that, the expense of, we're talking about minimal expense as compared to I mean, the cost of actually having to absorb this type of damage. I'd like to talk a little bit about that. Who should be in charge? You know, NASA is obviously involved with the efforts of identifying this and with the Jet Propulsion Laboratory and the assets that we're talking about. And NASA has been tasked with this. Once we determine that there is a threat, Rusty is suggesting that this is no longer a science issue. This is a defense issue at that point. Should the Defense Department be the ones who are then tasked with immediately taking over responsibility? Who should have some ideas as who should then be the entity that is responsible for planetary defense? Start with NASA and then work our way down.
Thank you, sir. Well, as you probably know, there is no one who is tasked specifically with that responsibility right now. That is not a settled policy question, and I think it's also fair to say that it would be something that would take the resources and capabilities of multiple federal agencies if they were to be so tasked. As Mr. Schweikert says about these things are safety issues versus sort of science issues, I'd also submit this is really a policy question. As to where you want to assign policy responsibilities for this and what sort of importance you want to give to it. I think NASA's traditional role certainly is stronger in the science and in the technology side of it, and therefore, you know, it wouldn't be obvious that we would be the lead agency for something like that. Although, if so directed, we would certainly participate with other federal agencies who were assigned.
Thought on that?
Mr. Rohrabacher, I would like to comment just a bit, and I thank you very much for highlighting that issue because, as I said, I believe this is really the most important single issue before the world, frankly. It's not only the United States, the Congress and the administration, but this is a global issue. It is not a national issue.
Well, the first part of it is, are we going to do what's necessary to identify the threat? And then the issue is, who's going to do it?
Right, and I think that the identification of the threat has been relatively well dealt with. NASA has explicit responsibility in terms of discovering. The identification of a threat comes right up to the point of warning, and issuing warnings has not been assigned to anyone, including NASA. So that assignment has not been made. And I think that, in fact, it probably was avoided at the time, several years ago, because of this fundamental policy question. Who is to make these large international policy decisions? And I think that it is important that we look at the logic of it and who should be involved. NASA clearly is the world's premier agency for developing and testing and demonstrating space capability. And space capability is the sine qua non of protecting the Earth against asteroid impacts. However, the policy issues are a larger issue, which involves cooperation between nations, agreements, trade-offs of risk, and many, many other things. And so the policy issue is somewhat separable. Now, the Department of Homeland Security, it would seem, on plain reading of the language, might be one logical agency. The Department of Defense is clearly another potential agency, and NASA itself has many international responsibilities, for example, the International Space Station, in which it makes policy decisions on behalf of the nation. So, to me, those three agencies are the prime candidates. I frankly, because of the need for international cooperation and worldwide public confidence, would argue against the Department of Defense being the principal agency. The Department of Homeland Security certainly has a large responsibility, but it seems to me that the Congress needs to hold hearings to allow many, many people and perspectives and issues to be openly aired in this regard. But it's extremely important because these international decisions are being forced on us by the very search programs that we've been talking about. In the next 10 to 15 years, we're going to discover hundreds of thousands of asteroids. And some of them, probably in the hundreds, will look as though they're headed for an impact. And somebody is going to have to make a decision within the next 15 years of do we or do we not take protective action. Now, those decisions are going to involve trade-offs between nations and national policy issues. And it seems to me we need to get on with this critical decision so that we're in a place to contribute.
Thank you very much. And, Mr. Chairman, I appreciate your holding this hearing, and I'd like to personally thank the witnesses. This has been very illuminating and not hair-raising. Thank you.
Well, I thank the gentleman of California, and I know within his political party and his circles there's a lot of debate about the prefix neo and to which words you then apply. But I sense that Mr. Rohrabacher may be more of a neo-internationalist now than he perhaps has been in the past when it comes to supporting a worldwide effort to make sure that the planet doesn't suffer from one of these impacts. We're approaching another vote. I'd like to ask a couple of additional questions of the panel, and then my questions will conclude the hearing. And I wanted to start with Dr. Green. NASA is planning to replace the existing deep space antennas at Goldstone with an upgraded system. Will NASA maintain the current planetary radar capability at Goldstone as part of the upgrade? And if not, why not?
Indeed, the organization in NASA that manages the Deep Space Network is the Space Operations Mission Directorate. They have the responsibility for developing an evolutionary plan for that system. It's used for communications in addition to the science that we utilize that system for. And our radar requirements have been given to that organization as they develop their plan. In the near future, we anticipate seeing those requirements met in the newly redesigned Deep Space Network.
Dr. Yeomans, how important is it?
How important is it to maintain the radar with the DSN? I think it's very important. As was mentioned by a number of folks on the panel here, the Goldstone radar and the Arecibo radar are the only two we have in terms of planetary observations, and they're very complementary. Goldstone covers a large area of sky. It can actually track the objects, whereas Arecibo is fixed and can track 20 degrees on either side of directly overhead. So very often an object will come into the Arecibo window, pass out of it, and pass into the Goldstone window, so and vice versa. So it's important to keep both of these facilities robust.
If I could, I'd like to follow another line of questioning, but start with Dr. Yeomans again, and just give the panel a heads up. I invite each one of you to comment before we conclude the hearing, and that the focus will be where do we go from here. NASA submitted its report to Congress on options. The expanded NEO program for approaches to deflect NEOs.
What do you believe, Dr. Yeomans, the relative priority for resources should be between NEO detection, tracking, cataloging, characterizing, and development of deflection approaches? In other words, what's most important to do next, and what specifically should NASA do next? Easy question, I know.
Well, I'm a bit biased. We have to find them early was my first, second, and third priority. And I do think finding them is the first priority. Obviously, we can't mitigate if we don't find them. We can't characterize if we don't find them. Having said that, we do need to characterize because there's an enormous diversity amongst near-Earth asteroids. They range all the way from a fluffy, wimpy ex-cometary fluff ball to a rubble pile to a slab of solid rock to a slab of solid iron. So you wouldn't mitigate each of those objects with the same technique, perhaps. So we do need to characterize these objects, and we do need to at least study techniques for mitigation. There's computer simulation work that needs to be done to understand how an impact or an explosion would interact with a rubble pile with a slab of iron. So we do need to understand the mitigation and the characterization, but I think discovery is still the most important.
Dr. Campbell, Dr. Tyson, Mr. Schweikert in turn, would you each like to comment on the question of priorities?
I think there's little doubt that discovery is the most important thing. If you don't know, if you haven't found them, you certainly can't track them and characterize them. It's clear that that there's little point in just making a catalog of a lot of objects in the sky that with poorly defined orbits. Therefore, I think that the two, orbit determination and discovery, have to go hand in hand. The most important thing to do is to cull the number of objects that you've found as quickly as possible so that you can actually concentrate on the ones that actually do pose a threat. We're talking about thousands of potential objects here. We're going to be finding tens of thousands. We need to know which ones of those are a potential threat to Earth. And for the very smallest objects, we have potentially very little time to do that in terms of the fact that they'll be rather close to the Earth in terms of their orbits and pass away rather quickly and not be detectable for some time in the future.
Dr. Tyson.
Thank you, Chairman. Discovery involves obtaining orbits. You can find a rock that's in the sky and then lose it, and it's of no use, and that doesn't count as a discovery. So with LSST, one sees each one of these asteroids 100 to 200 times, even more. So it's possible to derive a pretty good orbit for those and distinguish them from the background. So that facility would get orbits for the Earth-threatening, so-called potentially hazardous asteroids. What's not widely known is that we observe the whole sky every several nights. We just repeat the whole sky every several nights, often in a different color band. So we have a huge amount of color information in a 6-color system on each one of these Earth-threatening asteroids. And that, it turns out, as you might imagine, tells you a fair amount of information about the character of its surface and what it's made out of. So we will gain some knowledge for characterization as well from this data. But I think we need, actually, the bottom line, I think, is we need to start this process of discovery. I agree with Don that one has to actually discover these things and get their orbits first. And that involves a multi-agency cooperation in these new facilities. I'm thinking of the Department of Energy, Office of Science, NASA, and the National Science Foundation.
Schweikert.
Yes, Mr. Chairman, thank you. I'd like to suggest that the way in which you've posed the question is somewhat purist, if I guess I would use the word. Like most things in life, we're confronted with things which they can be posited as either or, but the reality is that they're usually not. And I would suggest that this is the case here. There is absolutely no question that finding them is absolutely the highest priority. Finding them early is very critical. At the same time, the most important thing to keep in mind is that we're finding them in order to protect the Earth from impacts. And so I would also suggest that at the same time that we're spending money on finding them, we can also direct JPL or NASA to put 1 or 2 people to thinking about and working through and understanding the ultimate issue of protecting the Earth, mitigating ones that would be coming at us. And right now, unfortunately, that additional task of thinking